In this video, I'm going to go through a couple of examples of writing equations of functions based on their parent function and transformations given a graph. So when I look at this first graph here, this first function, I see this is a square root function. This belongs to this family y equals the square root of x. And with that one, I know the basic shape is like half of a sideways parabola. I know it starts at the origin and it goes up to the right. So when I look at this, the first thing I'm going to notice is it doesn't start at the origin. It starts at this point, -3, 5. So I know I have a translation. So this is going to be left 3 and up 5. So that gives me right now, I have left 3, it's going to be the square root of x plus 3. Up 5, I know I'm going to add 5 to the end. I'm going to have some, is this dilated or not? I always have to consider there's some dilation on here. I do notice, though, that it normally goes up to the right. This is going down to the right. So I know that A must be negative because there is a vertical reflection. At this point, all I need to do is find a value for this. Whoops, let's get rid of that. Find a value for A, and I have the equation. So to find the value for A, I only need one value, so I need 1 point. I use the origin to get the start of the square root to get the translation, the +3 to the +5, so I need another point. So I'll look at a point that's easy to read. I'm going to take this one. This is 1, 1. So I'm going to plug this, or in other words, f of 1 equals 1. So I'll plug that into this equation, and I'll get 1 equals A times the square root of 1 plus 3 plus 5. This is an equation I can solve for A. So I'll subtract 5 from both sides. I get -4 equals A times the square root of 1 plus 3 is 4. So -4 equals 2A. So A equals a -2. And I said A must be negative, and A is negative. That kind of comes out in the wash. So now I know my equation is going to be f of x equals a -2 times the square root of x plus 3 plus 5. So let's look at another example. When I look at this one, I see this is a parabola. This is of the family y equals x squared. Again, y equals x squared, I know is going to open up. It's going to have a vertex of 0, 0 at the origin again. Take a look at this one. Tries to give me a different color again. Here the origin is going to be at 5, -4. Not the origin, the vertex. So I know we have a translation. And this is going to be right 5, down 4. So my basic equation is going to be, I'll use function notation here, because I used it before. Let's be consistent, right? Yeah, I like that color. This is a new drawing program. I'm not sure if I like it or not. F of x equals, and I know it's a square, so I'm going to start up my basic form. I'm right 5, so that's x minus 5. I'm down 4, so I will subtract 4 outside. And again, I will have a dilation factor I have to figure out. Now this one, there's no reflection, so I'm good to go there. So I know A is going to be positive. A is going to be greater than 0. I know it can't equal 0 because then it wouldn't be a parabola. So we'll again pick a point that looks reasonable. So I'm going to take this one here. This would be the point 11, 5, 6, 7, 8. Or I can say f of 11 equals 8. So we plug this in. 8 equals A times 11 minus 5 squared minus 4. Now we just work that out. We add 4 to this side. Because again, we just have A to solve for. 12 equals A times 11 minus 5 would be 6 squared. So 12 equals 36A. And we get A equals 1/3. So my equation is going to be f of x. Oh, again, positive, no reflection. That double checks with what we know is going on. F of x equals 1/3 x minus 5 squared minus 4. The main thing when we are doing these is if we can find the translation first, we're generally down to just solving for that one value, that dilation. The reflection is in with the dilation, because as you see here, this was no reflection. I got a positive A. On this one, I did have a vertical reflection. I have a negative A. Most of the time when we're dealing with these common functions we're working with, I don't have to worry about horizontal reflection. That should work out in there. Well, I will have to worry about horizontal reflection. I probably should have done one of that. Maybe ask that in class if you still have questions. The dilation, though, is always going to be, we can do that with a vertical dilation. So we just put in our factor of A, and then we just need one more point to solve for it. So take a look and keep working with these.